Alright guys, so today we're going to run through some intro notes on 9.1, which is the next chapter in the book that we're going to do. So I have this note sheet here. The blank file was linked, or you can just kind of take notes on a sheet, and at the end of this video you can take a picture of your notes and send that in for a grade today. I'm hoping a lot of this is familiar back from geometry, so I'm going to run through kind of fast to start. But we're starting off with SOHCAHTOA, so that's trigonometry, our sine, cosine, and tangent. And the first thing we need to do is just figure out how we label our triangle. So this guy's a right triangle, and we're going to be focusing on this angle right here. And a lot of times we'll use theta, that Greek letter, to represent an angle measure that we're looking for. And then if we have theta, the side right next to it, we call the adjacent side, and the side across we call the opposite side. And then since this is a right triangle, our largest side is our hypotenuse, and that's always the side across from our angle theta. All right, so that's labeling our triangle. And then SOHCAHTOA is a little kind of, what do they call it, mnemonic device to remember our 6 trig functions. So down here, we're going to write them in. This is going to be our 6 trig functions. And the first trig function, which is what the S represents, is called sine of theta. And sine is the opposite side. So if this is our angle, we take the opposite side and we put it over the hypotenuse. So if the opposite side here was 5 and our hypotenuse was 10, then sine of theta would be 5 over 10, or 1/2. So sine is opposite over hypotenuse. Now we will go through in this video and this year the reciprocal functions, which means we flip our fraction, and that would make this guy hypotenuse over opposite. That trig function is called cosecant. Cosecant. And this guy is spelled sine up here. So that would be, in this picture, 10 over 5. So depending on what they're asking for is going to be the ratio. These are all just taking fractions, taking sides from our triangle. All right, so that's that to start. So remember, you can pause this, fast forward, whatever you need to do. I'm going to write out the rest of them now. So the next one's going to be our cosine. And we abbreviate that COS. And cosine of theta is the adjacent side over the hypotenuse. So in this triangle, let's say the adjacent side is 5, and the hypotenuse is 12. Whoop. Then our cosine would be 5/12. So like I said, that's our adjacent over hypotenuse. The reciprocal function of cosine, so the hypotenuse over adjacent, is called secant. And that's abbreviated SEC. So again, you guys can pause, whatever you need, make sure you get these notes down. And last but not least is our tangent. We abbreviate that by tan theta, and that's OA of the SOHCAHTOA. So that's our opposite side over the adjacent side. So let's just do an example for this one. If our opposite is 3 and our adjacent is 4, then tangent theta would be 3 over 4, opposite over adjacent. This guy, our reciprocal, is pretty easy to remember. We just put a co in front of it for cotangent, and we abbreviate it COT. That's adjacent over opposite. All right, so I'll zoom out a little bit, and if you need to take a second to get these notes down, again, you can do them on a scrap sheet. I posted the video up there for you. Right, that's that for those. All right, so we're going to take just a minute, and I'm just going to start you guys off on these examples, and then you're going to finish them up for our work today. So one of the problems that we'll see in this section is evaluating the 6 trig functions for an angle. And they gave us an angle theta over here in this picture. So we want to find sine theta, cosine, tangent, and the reciprocals. Right, so if this is theta in our picture, I'm going to label, then this side all the way across, this is going to be our opposite side. And the side closest is going to be our adjacent side. So for the sine, that's SO, S-O-H, SOHCAHTOA, we need the opposite over the hypotenuse. And we might see that we're missing the hypotenuse here. We can find that using Pythagorean theorem. So 5 squared plus 12 squared equals hypotenuse squared. So we throw these guys in the calculator. Grab mine really quick. This is also a Pythagorean triple, if anyone remembers what those are. We get 169 equals the hypotenuse squared. And then in your calculator, take a square root. And we get 13. So our opposite side is 12. Our hypotenuse is 13. So that's our answer for sine. All right. So you guys are going to do the same thing, but cosine, right? You're taking the adjacent over hypotenuse. Tangent is OA, opposite over adjacent. And you need to write out our answers for these, along with their reciprocals. So check back on the first page if you need, and write those fractions in there to finish up this first example. You can pause me and do it now, or come back to it later. All right, so like I said, we're going to set these up for the rest of them. So for example 2, it says theta is the angle of a right triangle. So we'll draw a right triangle here with angle theta. And sine theta equals 4/7. So remember, sine from SOHCAHTOA, they're giving us the opposite over the hypotenuse. So I can draw this in my picture. Here's the opposite side. And they said that's 4. And the hypotenuse across from our right angle is 7. So they want us to find tangent of theta, which is our opposite side, over the adjacent side. And we do have the opposite, but we're missing the adjacent. So you're going to use your Pythagorean theorem, right? We have a squared, we're missing the other side, b squared equals our hypotenuse squared. And I want you guys to solve through so you can put your adjacent side in there. So you're going to finish up that guy. All right, last but not least, we have our special triangle reminder here. And that's just that if we have a 30, 60, 90, so this guy we call a 30, 60, 90 triangle, or a 45, 45, 90 triangle, we have kind of a setup to remember the sides. So in the 30, 60, 90, across from 30 is our smallest side. So this guy is the small side. We usually call that one X. Our biggest side is our hypotenuse. Writing with my rainbow pen. We call 2x. And the middle side across from 60 is x root 3. Right? So let's say, for example, in this triangle, x equals 1. then this side would be 2 times 1, which is 2. And our last side would be root 3, if we actually put some values in here. 45, 45, 90, the two congruent legs, we just call them x and x. And the big side, the hypotenuse here, we say is x root 2. All right. So with that in mind, you have to identify what's what, right? So I'll just get us started for these. Like this one, this is the small side, so we call that x. So you got to find what the big side would be and what the medium side would be. Right. Over here, we've got another one. That's a 30, 60, 90, and I gave you the small side again. So you got to find the other two sides. And our last one, I gave you this x root 2 side. So you got to figure out, right, what just x would equal. Think about how you get x alone there. So you guys try out those examples. I'll be on Zoom later to help you out. And then make sure you take a picture and post this for your homework grade today.